Okay. Can everyone can see my screen or hear my voice?
Yes, we can see your screen
Okay.
and hear your voice.
Okay.
Please.
Okay. Okay. So, hi, I'm Jojo, and today I will present the introduction of the 5G beam management and MIMO mapping. So this is my outline. First, I will divide the presentation into two parts. First is beam management, and this part I will discuss what is beam forming and why we need beamforming and how to control the beams. And second part is how does NR do a MIMO layer mapping. And finally, I will conserve some time to let everyone ask the question. So first is beam management. And first of all, we need to, I want to talk about what is beamforming. And it's a kind of signal processing and emits the power to the specific direction to the specific user. And how to achieve it is because antennas, multiple antennas superimpose the different power from different antenna to strengthen the signal, and so that it can be easier to reach the UE. So why do we need beamforming? Because for lower frequency domain, okay, maybe it's fine because the decay will not be very serious. So it can be easily to reach the UE. The power can easily to reach the UE, but in very high frequency deployment, we must do it. We don't have choice. We need enough power to confront the serious decay. So because beamforming is very complex technology, so we need very complicated mechanism to manage the beams. So how to manage the beams? And we want to talk about is beam sweeping. And what is beam sweeping is transmitting the beam to the specific direction at a specific time, and then change the direction a little bit, and in the next time frame, and then transmit to a different direction in turn. And beam management, I think I can briefly divide into two steps. First is initial access, and second step is connected status. And in terms of initial access, the main concept is to provide all of the beams to UEs to let UE do the selection. And something we need to remember is one SSB, that means it means synchronization signal block, and it correspond to one beam. So we can move on to the next page first. And that means if we only have SSB in a time period, we can only send the S beams in a period of time. Okay, that's what I want to mention in the second item. And so after UE gets all of the selection of beams, UE will do the measurement and get the best beam and report to the base station. And for example, UE gets the of the strength of all of the beams, and for UU1, it considers the second beam is the best, so they will report it. They report the result back to the base station. So after the initial access, it will enter the connected status. And they were divided into procedure P1, P2, and P3. And procedure 1 is also provide the selection, but different from the initial access. It provides the selection is after RRC reconfiguration. That means there's some configuration is changed on the base station side or on the UE side. So for P2 and P3, it will do a refinement on the base station or on the UE side. What is refinement? And we can interpret that is to narrow the scope of beam sweeping, so that they can reach the UE precisely. So now I want to demo the concept for these two concepts. Okay. So the first one is the shape of the beams and the relationship of the shape of beams and the number of antennas. And we can see every number represents the phase. And if the more number of antennas, and we can get the apparent direction of beams. And second one is how to control the direction of beam. And actually, it just use the order of the transmission. For example, the far left side, if the far left side of antennas transmits first, and then after all of the antennas transmit in order, they will form the apparent direction of the power. So that they can strengthen the signal. And okay. And then is MIMO layer mapping. And today what I mainly focus on is these two functional blocks. And first is the layer mapping, and second one is antenna port mapping. And actually, we can also call this functional as pre-coding. So first of all, we need to figure out what's the definition of string and antenna. And string is, I think we can refer it to an individual message flow, and we can get the information from this figure, and different beam, one beam will correspond to multiple antenna, and there's not really apparent relationship between the string and the antenna. So how how do they do the mapping? So for layer mapping functional block, they will divide a single string into multiple layers. And a concept I want to mention here is the number of layers must be less than the number of antennas, because sometimes we want to do the diversity. That means we need to send the same signal and message from different antennas to increase the reliability. So let's move on to the pre-coding functional block. And pre-coding is, this functional block is to provide a predefined matrix to do the calculation of a matrix. And this matrix represents the channel condition. And it is already be inverted. And this function block is can also map the antennas and layer based on the channel condition. And the procedure is that get the information, channel status from the parameter called CQI. The whole name is channel quality indicator, and then determine which predefined matrix to be used. So finally, I want to briefly go through all of the functional block. And at first, the base station will impose the code word on each string. Each arrow will represent, it is represented as string. And then it do scrambling to disperse the arrow, and then its modulation mapping. This block is referred to digital modulation, and then layer mapping I just mentioned, and then do the pre-coding and based on the channel condition, and then resource element mapping, and to allocate the signal on the specific resource element, and finally to generate the real carrier and signal, and then emit. And that is all my part. Any questions?
Thank you. I have some quick comment. Actually, you first of all, please add the link for your demo directly to the slide, so we are able to click the link directly. Second, if you refer to the figure, you have some source, you need to add a reference source such that we can check the source of the figure that you cite. The third one, can you go back to the pre-coding you previous page.
Okay.
Your slide.
Yeah.
The next one. Yes.
Okay.
The pre-coding will get the information from CQI. So pre-coding will be done in the physical layer, right?
Yes.
So pre-coding matrix, you tell us you need to get the information from CQI and determine which predefined matrix to be used. The decision is made by physical layer or make layer.
I think this one I think I need to check.
You need to think about it before
Yes.
you show us. You need to think about it. You cannot just copy the sentence you load you found from the website or somewhere, and you just copy and paste. At least you need to think about it.
Okay.
You need to raise the question by yourself, or should be ready for answer the question. Okay, here
Okay.
this part is quite important. I suggest you can try to prepare your talk again based on what Dennis is doing. Actually, you need to show us the concept of the terms. Then, since Dennis already showed us a single antenna case, so you need to tell us how do we extend from single antenna to multiple antenna.
Oh, okay.
So I hope everybody can use the same template, can follow the idea defined by the others. I guess you don't talk to each other before this training course, right? But
I have the short discussion with Akmal.
yeah, but you don't check it with Dennis. Actually,
Oh, yes.
your talk, your training course should be unique. Should be highly correlated. Dennis show you the background knowledge. You should use the background knowledge to extend. Then Ekman can show us more the detail.
Oh, okay.
Do you understand? This is teamwork. Teamwork means that even for training course, you do not prepare a training course by yourself. You need to discuss with the others. You need to understand, for example, which part of the function already be implemented in OSC source code. And you need to think about it. If you want to extend it to millimeter wave, how do you plan to modify your scheduler? Right?
Okay.
That's your final goal. Study the background knowledge is not your goal. Your goal is to implement something on top of OSC code to support millimeter wave, to support MIMO.
Okay.
Okay? So
Okay.
all of you need to understand the code, understand what they are doing now. All the background knowledge you show us should try to find a correspondence description in the source code. For you, of course, you don't have it at this moment, but you can think about, you can tell us if you want to extend it to MIMO, how do you plan to modify the code? Which part, which of the source code, which of the file in the source code need to be revised, and how do you plan to revise it? Okay?
Oh, okay.
Try to think about it. It's good talk, but your correlation is not strong enough. Thank you.
Oh, okay. Thank you, Professor.